Hello everyone and welcome back to my YouTube channel. Myself Prasanna Mehta, studying in Sri Venkateshwara College of Engineering, pursuing my BE in CSCCY Cybersecurity. Today in this video we are going to discuss about the topic from the subject Mathematics, which has the subject code BCS 301, and the topic is ANOVA, the analysis of variance. ANOVA, or analysis of variance, is a statistical technique used to compare the means of two or more groups. It's a powerful tool to determine if there are significant differences between the groups or if the observed differences are simply due to random chance. Next, introduction. First, purpose. ANOVA is used to test hypotheses about the means of population by parting the total variation in a dataset into different sources of variation. Second, applications. ANOVA has a wide applications in various fields, including healthcare, engineering, businesses, and social sciences, where it helps analyze data and draw conclusions about group differences. Third, key principle. The core principle is to compare the variability between groups to the variability within groups. If variability between groups is significantly larger than the variability within groups, we can infer that there is a difference between the group means. Next, assumptions of ANOVA. First, normality. The data in each group should be normally distributed. Second, homogeneity of variances. The variances of the population from which the samples are drawn should be equal. Third, independence. Observation within each group should be independent of each other. Next, let us see the types of ANOVA, in which the first one is one-way ANOVA. In one-way ANOVA, the first step is the data collection. Collect data from each group being compared. The data should be numerical and relevant to the variable of interest. Second, hypothesis testing. Formulate null and alternate hypotheses about the population means of the groups. The null hypothesis states that the means are equal, while the alternate hypothesis states that the least one means is different. Third, ANOVA calculation. Perform the ANOVA test to calculate the F statistic, which measures the ratio of variance between groups to the variance within groups. 4. Interpretation. Compare the calculated F statistics to the critical F value from the F distribution table. If the calculated F statistic exceeds the critical F value, reject the null hypothesis and conclude that there is a significant difference between the group of means. Next, interpreting one-way ANOVA results. That is a table which has the mean, standard deviation, and F statistics with the p-value, through which we can get the one-way ANOVA results. Based on the table above, we can see that F statistics is 5.67 and the p-value is 0.012. Since the p-value is less than the significance level of 0.05, we reject the null hypothesis and conclude that there is a significant difference between the groups' means. In other words, at least one of the group has different mean from others. Next, the other type of ANOVA is the two-way ANOVA. Two-way ANOVA is used when you have two or more independent variables or factors that you want to investigate their efforts on the dependent variable. It allows you to test for main effects for each factor and also for interactions effect between the factors. For example, if you are studying the effect of different types of fertilizers on a crop yield, you also want to consider the effect of different watering schedules. A two-way ANOVA would be appropriate. It would allow you to see if there is a main effect of fertilizer type, a main effect of watering schedule, and if there is an interaction between the two. Next, interpreting two-way ANOVA results. In addition to the main effects, the two-way ANOVA also investigates interaction effects. An interaction effect occurs when the effect of one factor depends on the level of the another factor. If, for example, in a fertilizers and watering example, we might find that a particular fertilizer type is most effective with a certain watering schedule, while another fertilizer type performs better with a different watering schedule. This would indicate an interaction effect. ANOVA and hypothesis testing. First, null hypothesis. The null hypothesis in ANOVA states that there is no difference between the group means. This means that the observed differences are due to random variation. Second, alternative hypothesis. Alternative hypothesis states that there is a difference between the group means. This means that the observed differences are not due to chance and there is a real difference between the groups. Third, test statistic. The test statistics in ANOVA is the FS statistic, which is calculated by dividing the variance between groups by the variance within groups. Fourth, p-value. The p-value is the probability of obtaining the observed result if the null hypothesis is true. A small p-value, typically less than 0.05, indicates strong evidence against the null hypothesis, suggesting that the group means are different. Fifth, decision. If the p-value is less than the significance level, we reject the null hypothesis and conclude that there is a significant difference between the group means. If the p-value is greater than the significance level, we fail to reject the null hypothesis and conclude there is no evidence to suggest a difference between the group means. Next, limitation and considerations. While powerful, ANOVA has limitation. It relies on several assumptions that must be met for the results to be valid. For instance, the data should be normally distributed within each group and the variances of the group should be equal. Violation of these assumptions can lead to inaccurate results. Additionally, ANOVA is sensitive to outliers, which are extreme values that can significantly influence the results. Outliers should be carefully examined and addressed as they can distort the analysis. The sample size also plays a role in the power of ANOVA, with larger sample size providing more reliable results. Next, conclusion and key takeaways. ANOVA is a valuable tool for comparing the means of two or more groups. It allows you to test hypotheses about population means and draw conclusions about the difference between groups. It has a wide application in various fields and can be a powerful tool for making informed decisions based on data. However, it's important to understand the assumptions of ANOVA and be aware of potential limitations. By carefully considering these factors and appropriately interpreting the results, we can leverage the power of ANOVA for meaningful insights and informed decision making. Thank you for watching my video. Please like and share the video.